Hello, it's Keith here, and this is lesson 12 of the simple series of my 68000 assembly programming tutorials. Today we're going to be looking at the NeoGeo. We're going to take this previous smiley example where we had a smiley on the fixed layer. We're going to add joystick controls and move it around the screen. So this is going to be an example of how you can have joystick controls in your game and have an object moving around, and hopefully this will be helpful to you if you're getting started programming this system. Now this example is later extended. I'm going to do a video later where I extend it into a little game called YQuest, and this just shows that this code could be used for making your own game if you want, and we'll be extending that further in the future as well. Okay, well first of all let's just fire up today's example and check it actually works, because sometimes they don't. Sometimes a bug has crept in, but hopefully it won't. Okay, so here's the example. If I just make it a bit bigger, here we go. Okay, so you can see we've got our smiley here, and I've got cursor keys mapped to simulate the joystick here, and you can see we can move the smiley around the screen, but we can't go off the screen here. We are fixed within the visible area of the screen there. So we've got joystick control working, and we've also got some range checking, and today we're going to look at the code that is doing that. Okay, and here it is. Now the first thing you can see at the top here, we've got some definitions of variables in RAM here. We've got 2 for the current position of the player and 2 for the player's previous position, and that's going to be used for resetting the player's position if they try and go off the screen. These are words, these are 16-bit values here, and that's going to be what we're going to use in our code today. Now you can see here we've got a generic header here. This was taken from this website here. I didn't write this myself, so we're using this very complex header that we do need to make our game cartridge start here. Now the actual start of the code is basically here. And this is the actual start of our code. We've got to do this kick of the watchdog thing. Now this is to stop the hard reset hardware that will make sure the game hasn't crashed from resetting the machine. So we have to do that regularly. We do it just here. We're then initializing our colors here, running some firmware functions to clear the screen and the sprites, and we're then initializing the starting position of our sprite here. Now what we're doing here is we are then going to start drawing our sprite. Now we've got our read controls routine, which will read in from the joystick, but we will wait usually until a key's been pressed, but the first time we will need to show the starting position, so we jump over that to the start draw routine just here. Now let's take a look at our drawing routines and our joystick routine first. So we have previously had this draw sprite routine here. This was basically what we were using for the smiley in the simple series, and we've just changed it very slightly. We've now got 2 versions, one that uses sprite 512, which is the smiley, and one that uses sprite 513, which is a blank sprite. Now you'll notice there's no bitmap data here, and if you've forgotten or if you don't know, we can't define our sprites in software. They have to be defined in ROM files. There's no VRAM for the pattern data within the NeoGeo, so it's all actually done by the XML file. Now if you see this file here, you will notice that there is a entry in the ROM section here. This section is called fixed because this is the fixed layer, and we've got a file called raw neo smile.fix here. This is a file I created. It's got that smiley tile and also the blank tile in it. You can see it's very small here, and we've got a calculated CRC and a hash here, a SHA-1 hash here, and these were calculated by a little program that is available in my examples. So if you go to my website and download all the sources, you'll get all this kind of example code, and it should allow you to hopefully run the program as is without any work. But we do have to put our graphics in the ROM, which is quite annoying, but it's just the nature of this machine, unfortunately. So this is defining the tile as being visible on the screen. Now you'll notice here is our read controls dual function here. This is very, very straightforward here. Now we've basically got 3 ports we need to read from. 38 quadruple 0 here will load in the select and the start buttons and the card ports if we want to read in those. Now the actual directions and the 4 fire buttons are from 3 and 5 zeros and 3 for quadruple 0 here. 3 and 5 zeros is up, down, left, right from 4 fives for joystick 1, and 3 4 quadruple 0 is for joystick 2, and very easy. We can't really complain about that. That's as easy as we could get. So very nice there, nicely done, NeoGeo. So that's what we're reading in from in this case here, and then we're just moving that into D3 for later. We're then checking here to see if any directions have been pressed. If not, we're just going to wait until they are. Once they are, we're then backing up the current position of the player, clearing the old sprite off the screen, and then we're checking all 4 directions, and we're moving 1 tile accordingly in the correct direction if any directions have been pressed. We're then saving the new direction here, and then we're going to check if the players tried to go off the screen. Now in my tutorials I'm using a 16-bit number for each of the X and Y position, and the top corner of the screen is 0,0. If you go below 0 in a register, you'll wrap around to 65535. So I'm never checking a minus value, I'm just checking the top boundary, which will effectively check below 0 as well. So we're just checking the X and Y boundaries here. If the position's okay, we jump down to here, and if it's not, then we reset it. We are resetting here by loading in the old values of X and Y and just writing them over the current value before drawing the player, and that will reset the player's position. And then we've just got a simple delay here just to wait for long enough so we can actually see what's going on. And that's really all there is to it. Now, as I say, we're going to extend this further in the future. We're going to basically put it into an entire game. The game's called YQuest. You can see I've already got the graphics ready for it here. So if that interests you, if you want to see this taken further, then please stick around and you will see that later. And we'll be adding hardware sprites to it as well at some point in the future, because at the moment we're just using the fixed layer for simplicity. That's the easiest way to get started. But obviously hardware sprites are going to be a lot better. So that's what we will be doing. Anyway, that's all we're covering today. The NeoGeo has made reading joysticks very easy for us, so it's a short lesson. I hope you found it interesting. If you have, please like and subscribe. If you like the videos, YouTube recommends them to other people. And if you subscribe, the extra sub count gives me a little bit of motivation and what have you, so it helps as well. Anyway, whatever you do, I wish you all the best with your programming. I hope you have a lot of fun with the NeoGeo. Thanks for watching today, and goodbye.